We do have a few visitors tonight. And Mike, Ivany, if you would like to maybe just say hi to who's new here and help us greet them.
Well, thank you. Kevin, of course, is our speaker. Kevin, if you want to just shout out and say hi.
Okay, good evening, everyone. My name is Kevin Zanjani with Bioenno Power. I'm in Santa Ana, California. And we're going to have a presentation tonight about lithium iron phosphate batteries and how you can use it for your ham radio.
Kevin, we got a nice little introduction of who you are, where you are, all that stuff a little bit earlier. So I think now if you're about ready to give your presentation, I think we're all ready and looking forward to it. So
all right, very good. My name is Kevin with Bioenno Power, based in Santa Ana, California. This is a presentation on lithium iron phosphate batteries. I'm going to share this presentation. So this presentation is a general overview about our company. Over the past several years, we've been offering lithium iron phosphate batteries, which is a new state-of-the-art battery chemistry that replaces lead acid batteries that you're familiar with for radio applications, among other applications. We're located in Santa Ana, California. If you've come out to the West Coast, near Disneyland out here, near Anaheim, we're one city over, near the John Wayne Airport. Our website's up there at www.bioennopower.com, and my email as well, and phone number. If you have any questions, we're going to probably let the questions, we'll wait till the end of the presentation because of the format that we have here. It's probably the easiest way to do that. So a little bit about our company. We were founded in 2010. We're an OEM of lithium iron phosphate batteries and various solar products. We're based in Santa Ana, California, implemented both 14,001 and then 9,001 quality and environmental standards. We believe we're offering a world-class technology, after-sales service, warranty, and we do have customers that are based worldwide. This is a little bit of a map that we're showing in terms of where we're coming from as a company. You're based out in the Washington, D.C., Vienna, Virginia, that's the area. So some of these federal agencies, maybe some of you have worked for them, some of you may not. We do business with different agencies now. One of the agencies that we currently do business include DEA. They use our small power pack products that have built-in battery, USB output, inverters for powering various tablets and communications equipment out in the field. DHS is a customer that we're continuing to do business with. If you're familiar with Raspberry Pi, not Apple Pie. So it's a Raspberry Pi. If you're familiar with that, that's a small postage stamp sized computer. It has a CPU, has memory, quite a bit in a small package. So they're using that to power those applications, as well as the DOL. So DOL's involved with mining out in West Virginia. So there's a pilot that we're doing work on our 12-volt, 100 amp hour lithium iron phosphate batteries. They weigh about 33 pounds. They're very lightweight for applications where in mining, in that application, they're interested in seeing how that could be used for lithium iron phosphate batteries for that particular application out in the field over there. The Forest Service, U.S. Forest Service. So why would the Forest Service be interested in batteries? Well, your federal tax dollars go to various scientists that essentially what they do is they wear a fairly large capacitor on their back, and they use these 12-volt, 12 amp hour batteries, very lightweight, to charge these fairly large capacitors, and they stick a metal rod inside of the water, this is fresh water, and they shoot a surge of current, electrical current, into the water. The fish pop out of the water. They scoop up these fish. They measure the weight, the height, etc. The Forest Service is interested in the fishing industries. The fishing industry is a really big industry in this country, and it's a very interesting application of batteries. This is called it's a special pack that now scientists can purchase at the U.S. Forest Service. It is not something that you can get, okay, unless you're a scientist over there. So it's an interesting application of batteries as well. Up in Canada, we're doing business in the oil and gas industry, even with the conditions on the price of oil and gas. There's always interest in finding new sources of fossil fuels. And you'd be surprised, you wonder why would they be interested in batteries? Well, they actually use quite a bit of batteries in instrumentation equipment for oil and gas exploration. So if any of you work in that industry, they use fairly large tools that probe the layers of the earth to find these new sources of oil and gas, and that uses quite a bit of battery as well. And they deploy a lot of different sites as well. I'm going to talk more about that later in the presentation. We're continuing to do business with a lot of universities, MIT, the Naval Academy as well, among other universities out here, the University of California, many other universities as well, because they've implemented curriculums on both solar applications as well as battery courses now at the undergraduate and graduate school levels. So they're interested in teaching students how to deal with the renewable energy sector when they graduate. So what is lithium iron phosphate? So this is a new type of battery chemistry that came about in the past several years. To give you a bit of a context of where we're coming from, the technology came about in the laboratory in the mid-1990s, and it became commercialized around 2010. So it took a while to come to the market, and now it's established itself to be kind of a state-of-the-art battery chemistry in terms of rechargeable lithium chemistries. It's also known as lithium iron phosphate, lithium ferrous phosphate, LiFePO, LiFe. Has a very tremendous high degree of thermal and chemical stability, a very tight iron phosphate bond, enhanced charge cycles. We introduced the batteries in 2012, and they've been out there right now. We checked back with a lot of OEMs for the past 8 years, and they're still running strong. So it's kind of interesting how this battery chemistry is holding up over the past several years because of that cycle life that you get out of that. Now, it's different than the lithium polymer batteries that you currently use. Maybe if you're involved with RC model cars or quadcopters, those polymer batteries, that is based on lithium cobalt oxide. This is lithium iron phosphate packaged in cylindrical cells. So they get packaged in these kinds of cells here, and they're not pouch cells that you would see on a polymer battery or the type of polymer battery that's used in your phone. So the cycle life on those is a lot less, and also there's no internal circuitry inside of the battery itself, and it's not as stable compared to this type of chemistry. Now, in comparison to a lead acid battery, lead acid batteries, they're quite it's quite difficult to handle in terms of its sulfation. They vent. Lead is quite toxic. Whereas this one, you're dealing with a chemistry that's inherently safe because you have a very tight chemical bond. If you go on YouTube and look up lithium iron phosphate, you'll see some videos they put a nail through the cell, which is quite incredible in the sense from that standpoint. You're dealing with a high degree of stability in that sense. Lead acid batteries, probably took them out during field day. They're quite heavy, so you have to put them on a dolly or a cart to take them out there. Whereas this one's about a third the weight. This is a 12 volt, 12 amp hour battery. It's about 3 pounds. It's much lighter than a lead acid battery that you're familiar with. With SLA batteries, if you've ever left the SLA battery attached to some electronics, you'll notice that it has no protection built into the battery. So you can easily over discharge an SLA battery. So if, let's say, you leave your equipment on, you don't have a low voltage disconnect, it over discharges, and then you can't recharge the battery easily. So at a point at which the voltage gets too low, it's shot pretty much. But whereas these batteries, and every single lithium iron phosphate battery that our company provides, we put a circuit board built into the battery that protects against overcurrent, over discharge, under voltage, over voltage, and thermal protections. So what's interesting is, let's say you were to leave your equipment turned on. If I was to leave that equipment turned on at around 10 volts, the battery's circuit board is going to shut off that output. So in that sense, the cells inside the battery are protected. So that's really important in that regard. So in terms of that standpoint, it's very useful for ham radio applications if you leave your equipment turned on in that regards. Lead acid batteries, only about 50% is usable. There is an effect called it's called the Puchert's effect. Whereas if you were to pull, for example, in a 12 volt, 12 amp hour battery, if you were to pull 12 amps out of that battery, only about 6 amp hours usable, because the way they rate the battery, it's rated at what they call a C/20 rate. Whereas these batteries are rated at 1C. So you can capture nearly 100% usable capacity out of these batteries. And that's important because that means you can use a fairly small battery for radio applications. And we'll hit on that point later on. You can use most of the capacity out of these batteries. In terms of memory effect, we're not dealing with any memory effect. What's nice about this particular chemistry is you can be at any state of charge, 25, 25%, which means that you can use it for both cyclic and standby applications. So if I was to, let's say, use these batteries in a radio application, that's a cyclic application. I charge the battery, I completely discharge it, I recharge it, or if it's some kind of scooter application, like a motor application. And a standby would be telecom, for example, in UPS systems. Those applications are standby, so we could use it for both applications as well. Partial cycling. So what's the effect of a partial cycle? So in other words, in the battery industry, we talk about a charge cycle as a full charge, a full discharge. We count that as one cycle. Whereas this one, if I go half a cycle, that's considered a half a cycle, meaning I can extend out the service life of these batteries if I'm partial cycling these batteries, which is what we're seeing. We're going back to the early customers and saying, well, are those batteries done? They said, no, they're still going strong, which shows the fact that they're actually, may not be cycling completely every day. They may be partially cycling the batteries, and they're able to extend that service life out even throughout the year 8 that they've been out there. A few percent per year on the self-discharge, which is very convenient for use in a lot of different applications that might be out there in the field as well. So this chart shows you a lead acid battery. If I was to pull 1C out of a 12 volt, 12 amp hour lead acid battery, maybe about 50% is usable. So maybe 6 amp hours are actually usable depending on at that 1C rate. Whereas with the lithium iron phosphate batteries, I'm getting a nearly 100% usable capacity. You get a lot of questions about the circuit board that's used in the batteries. What's this circuit board? We keep hearing about it. So every battery has this protection circuit board because internally in the battery, they're assembled with several cells that you see here, and then they get packaged with the circuit board shown on the screen into something that looks like this with connectors that come out of the battery. And then that circuit board that's built in, what it's doing is it's equalizing the cells that are inside the battery and providing that balancing and equalization. So that's internalized in the battery. Whereas other batteries that don't have circuit boards, they rely on a special charger that provides the balancing and equalization. In this case, that's built in. Over voltage protection. So if I'm hitting with a high voltage, it does a disconnect. Over current protection. So if I pull too much current out of the battery, it's protecting. And then also that over discharge protection, which is very useful. At around 10 volts, that battery is going to shut off. And short circuit as well as temperature protections. We also have questions about the specifications. We can provide you these specifications if you want to build your own charging system. Some customers, they want to build their own charging systems. So we provide you the PCM parameters if you need that, if you're interested in building something on your own. We do have power supplies, chargers, and I'll explain more about that later in the presentation. The internal impedance is quite small on these batteries, and what's nice about it is that internal impedance is not varying greatly as the battery ages, unlike a lead acid battery. Whereas when it sulfates, a lead battery, the internal impedance starts going up, you start getting more voltage drop, you pull more current out of a lead battery, the voltage drops even further. This is staying quite constant as you load the battery, just stays up about 13.2, 13.1, 13.4 volts in that range. And so the battery can deliver to the load, which is pretty important for use in various applications. This is a very interesting graph showing the discharge curve. So what you'll notice here is how flat it is for a lithium iron phosphate battery. This is a 12 volt, 20 amp hour battery pulling about 4 amps. You'll notice that it's just very, very flat across its discharge. The way you read this is on the y-axis, there's the voltage, and then on the x-axis is the amp hours. And if you take a look across that 95% depth of discharge, we don't get that dip and sag. But you'll notice at the tail end, there's that cliff, or they call it the cliff or the knee, or falling off the cliff. That's the battery's circuit board shutting off the output. So it just stays flat and then shuts off. Now, what's important, we have to emphasize, is the battery cells internally are sitting at voltage, okay? And what you're seeing as a user is a battery that shuts off, okay? So you're okay if it shuts off. That's built in, that's a feature of the battery to help determine that it's gonna protect the cells at that point. Some customers, they wanna know, well, if it's so flat, how do I know how much of the battery I've used? Very common question. I'm used to a lead, you know, they say I'm used to a lead acid battery, that voltage drops, I map it to the amp hours that are used. In this case, because it's so flat, you need to use a Coulomb counter or DC inline watt meter. It's available through HRO, PowerWorks, various dealers as well. It's a little shunt meter that you put between the battery and the load to give you how many amp hours that are consumed. So that will help you in figuring out when the battery is going to turn off. The available capacity versus temperature. So this is very interesting. Lithium iron phosphate versus an AGM, absorbed glass mat, which is a type of very popular lead acid battery. You'll notice that even at very low temperatures, minus 20 degrees C, this is where we see a lot of AGM batteries, they can't keep up. And you'll notice when you go out in a very cold winter day and you were to operate an AGM battery at, you know, minus 20 Celsius, about 14 Fahrenheit, a very cold day, maybe only about 30% usable. This is still over 80%, 85% usable, even at those cold temperatures, which is why up in Canada, Alberta, Saskatchewan, Manitoba, really cold places, they're starting to adopt the lithium iron phosphate batteries for their applications in various sensors and equipment. We get a lot of questions about runtime. So how do I calculate based on the power? So this was on the exam. Power is the volts times the current. Get 10 watt continuous. So if I was to have a continuous 10 watts on a 12 amp hour battery, for example, this would be an example of a 12 amp hour battery, 144 watt hours, 10 watts, about 14 hours of runtime at a continuous power consumption. But with radio, it's a little different. Radio, we have a duty cycle, a weighted average power. This is a very important concept, especially when you're running ham radio equipment or commercial radio equipment off batteries. Because we're using a weighted average, our runtime is extended because we transmit at a higher power, the radio transmits at a higher power, and it receives at a lower power. Now, a lot of the modern radios, the receive power tends to be quite low, especially a lot of the software-defined radios. So we've seen batteries running across a very large time period, a 12 volt, 12 amp hour. I've seen on a very small QRP radio, like the KX2 or the KX3, the Ellercraft radios, and some other QRP radios, about a 40-hour runtime off something like 12 volt, 12 amp hour on a QRP radio. Depending on power levels, if you start going to 100 watts, then you have to go to something a little bit larger, a 12 volt, 20 amp hour, which is about 5-pound battery. It's about this big, and it will provide something to the effect of 10 to 11 hours. So we can still use a very small battery because you can use most of the capacity on these batteries, unlike a lead acid battery. I'm going to switch gears right now. We're going to talk about some things related to projects that customers have been working on, namely Go boxes. So these are really cool projects that you can do as a club. You can get familiarity with how radios operate off the lithium iron phosphate batteries. This gentleman, Michael Jones, built a Go box using a battery. He's using a 12 volt, 20 amp hour battery and a solar controller. And he's able to charge the battery off solar while operating the radio. So you can charge the battery with a solar controller that looks something like this. The controller, what it does is it regulates the voltage that comes off the solar panel in order to correctly charge the battery. You cannot hook up the solar panel directly to the battery. You need a controller to do that, and then you can build a go box to take out with you out in the field. This is Greg Lane, N4KGL, up down in Panama City, Florida. It's up in the top left there. They're operating field day with a KX3. They're using a 15 amp hour battery for field day, and they had a Slim Jim antenna as well. Switching over to, this is really cool. We're going to go to Norway. This is Norwegian amateur radio station LA9XJ. So many of you might be familiar with Summits on the Air. Hopefully membership participates in that. If you're not familiar with it, SOTA is it's a contest. Essentially, you go up to a lot of mountaintop sites. You make these what they call activations, and these mountaintops all over the world, and you get points and bragging rights, etc. So I'm going to read you what he wrote. This is Tor, LA9XG out of Norway. So he wrote, this SOTA hike started from my home Ixis Ranch at 0600 UTC, and it took me around 3 hours to get to the summit. Weather today was almost unbelievable, with -10 degrees and a clear blue sky, and the view from the summit almost indescribable. On this activation is using a Elecraft KX3 with 5 to 10 watts of output, 2 Bioenno Power lithium iron phosphate 12 volt 8 amp hour batteries, and a buddy stick multiband vertical antenna. I made a total of 153 QSOs on this remote summit activation. 153 QSOs, that's a lot of QSOs. And it gives you a sense of how the batteries perform at very cold temperatures. You can still perform quite well with this chemistry, unlike other chemistries available. If you're out in Norway and you're doing this, you need a tent, you need some skis, sleeping bag, and then you got a fire at night. So it's kind of a fun little thing you can do. I know many of you are interested in solar. So solar can be done. It's quite simple. What you need is a solar panel. So on the top left there, you'll see some examples of a folding suitcase style panel. This is also a folding panel that you can see here. It's a 28 watt folding panel, folds up, and you can goes in a backpack configuration. So you need the panel to generate that power, and then the battery, and then the controller. So there's 3 items that you need, and then everything is taken care of through the electronics and the controller, as well as the PCM circuit board and the battery. You can charge the battery while operating and keep things going in that regards for solar. We get a lot of questions about how many watts for the solar panel. You know, depends on the size of the battery. So if I have a 12 volt, 12 amp hour battery, again, something like this, and I was to charge it up using a 60 watt panel, it's about 2 hours. So I could use a suitcase style 60 watt panel, or I could get a couple of these panels and then I could connect them. They chain together. So if I put, there's a cable on the back of it, which lets you chain everything together to expand out the wattage. If you want something that's foldable and more portable than the suitcase style panels. Do I really need a solar charge controller? I just want to hook up the panel directly to the battery. So it's required. It regulates that open circuit voltage. So if you measure the voltage on what they call a 12 volt nominal panel, you're going to see a voltage somewhere between 18 to 21 volts, 15 to 22 volts. It depends on the panel. The solar controller then regulates that voltage so that the battery can correctly charge. You hook up the high voltage of the panel directly to these lithium iron phosphate batteries, you're going to trip the over voltage protection on the battery, and it won't take any charge current. So that's required in that regards. This is a very common question. Do I need a special charger for these batteries? So these batteries, they want a constant voltage current limited power supply. They can either be, you can either use a linear or switch mode power supply. That overcharge and over voltage protection, that's all built into the batteries. So you don't need a fancy balancing charger that you use, for example, in the radio controlled market for quadcopters or RC cars or something to that effect. Any voltage between 13.8 to 15 volts and the current limiting can be used to charge these batteries. What we do is, if you go to our website, you'll see where it says battery or battery plus charger. That charger is a current limited power supply that's matched up for the batteries. We pair it up so it's an easy purchase depending on the model of the battery. Now there's other, now a lot of other companies are supporting lithium iron phosphate batteries for charging. Later, I believe West Mountain Radio will be giving a presentation. They have a product called West Mountain Radio Epic PowerGate. The Epic PowerGate product is fully compatible with these batteries. There's an option in there for the lithium setting, and you can then set the current limiting on that as well. And there's other controllers available that now fully support lithium iron phosphate batteries. So that's come about in the recent 1.5 to 2 years. So that's completely available. So 13.8 to 15 volts after charging. The open circuit voltage is between 13.2 to 13.5 volts. This voltage matches up with radio communications equipment, about 13.8 volts, plus or minus 15%. So in that regards, it's very well matched with the radio equipment, and you don't need a booster. Customers are saying, well, do I need a battery booster with these batteries? Well, you're at 13.2. You're very close to the operating voltage for the radios, so there's really no need for a booster. What size of battery do I need? How do I know? So you need to know about your consumption and desired runtime. So a 12 volt, 12 amp hour battery, assuming a 50 watt continuous consumption, about 3 hours, 20 amp hour 5, 40 amp hour 10, 24, 100 amp hour 24 hours. This is for continuous power. But remember, we talked about earlier, we have a weighted average for radio. So we can actually get by with something fairly small in order to run the equipment. So for example, at 10 watts, I could be using something like a 6 amp hour battery, which gives me a fairly long runtime, about 12 hours. And then if I have a 20 amp hour, at 20 watts, 12 amp hour battery, it's about 18 hours. 50 watts, about 10 hours. And then if you're going to go to 100 watts, we suggest something a little bit larger. So you want to be at least, 15. I would say 20 amp hours gets about a 10-hour runtime. It tends to be sufficient because most hams, they tend to want to run the whole day. If they're out in the field or in a park or somewhere, they want the whole operation time for that whole day. So we found that the 20 amp hour tends to be quite popular at 100 watts. But it depends on what your weight, restrictions are, how much you want to carry around. I'm going to switch gears right now. I want to talk about the particular various types of applications for oil and gas industry. Southern California Gas Company is one of our customers. So natural gas tends to be stored in massive underground in order to buffer for demand. So right now out here in California, we have state laws requiring all gas companies to monitor for any leaks in massive reservoirs before there are any issues. We had a situation out here where there was some kind of leak and it was a big problem. And so now the state has more laws in terms of monitoring how these reservoirs emit any emissions. So what you'll see in this particular example is, if you look in the middle, that long cylinder, that's a gas sensor. So what that's doing is measuring how much is being released into the atmosphere. And then you'll notice there's some electronics at the top, and that's a data collection unit up there. And then our 12 volt, 20 amp hour batteries in the bottom left. So what this unit does is it collects information about how much gas is being emitted out of the reservoir, and then it gathers the information and has a built-in controller that's used via solar panels to keep it charged up, keep the battery charged up. Now you may be asking, well, why isn't there just power lines? Well, part of the issue is the reservoir is so massive, they're at the regions where they can't access, there's no powers, there's no mains that was put there. Could be in the forest or something to that effect. And so they require this type of system as all backups as well. So there might be restrictions on the mains power getting there. Also the backups required for batteries as well to send information. This is up in Canada, up in this company called Nanometrics in Ottawa. They do oil and gas exploration equipment. Oil and gas industry is quite large, not only down here, but up in Alberta and Manitoba, in really cold places. Oil and gas is found in really unusual remote areas. Usually they're not in your backyard. And so they needed something that was a better performance around -30 Celsius. So they're using a 12 volt, 20 amp hour batteries. And what's neat here is they have a solar based system, and they're using a KU band satellite uplink. to send the information, because there's no LTE cellular, there's no cell phone network to relay the information. They have a bandwidth requirement, and so they have to go to satellite communications in order to send the information. If we come down back to the US, in Louisiana and Laredo, Texas, a company called Flow Services, same kind of thing. This is a same concept, except this is using LTE cellular and radio packet, so they can deal with the lower data rates to transmit the information. So they use a radio packet system, 12 volt 20 amp hours, 12 volt 30 amp hours, and they replace the entire SLA AGM batteries with lithium iron phosphate. We've been going around to a lot of different events. I've probably seen some of you at Hamvention. If you had a chance to come out there, there's a lot of West Coast events. We're out here in Southern California. We were just in Orlando, Hamcation earlier this year. Should be also saying February 2020. So that was our last event before things got shut down for COVID. But look forward to seeing you guys later on. This is some of the photos. If you take a look at the upper left, there's some neat applications of batteries in terms of go boxes. This is another example where they've used like a Pelican case. They put the battery, there's some foam in there. So a lot of ways you can do it. He has a solar controller as well to kind of deploy. And I would encourage as an activity, if you get a chance to build a go box, because it'll help you understand how things are operating off batteries. Articles written in CQ magazine, and then the QST magazine article as well. KB1HQS, Stu Thomas wrote a really nice book. It's a 101 book for your membership that's just starting out in portable operations. All of the components to consider. He talks about the batteries in there, so feel free to check that out as well. We're in other industries, audio visual, energy storage, marine. So trolling motors and fish finders, they're starting to use lithium iron phosphate batteries, because in a trolling motor, they have very large lead acid batteries. And then, of course, radio communications and replacements for SLA, robotics, etc. Some more examples, some other power products that we have. And that's it.
Oh, that's really great. Thanks very much.
Yeah, thank you very much, Kevin. All right.
And then we'll open it to questions. If you want to probably just go around.
Yeah, that'd be great. So we'll open up for questions. If we can probably just let people speak up, but we do have one question to start out in the chat. Is there single cell failure protection? That's from John.
So what the battery does is it's monitoring across the cells inside of it. So they're hooked up into, the circuit board has jumper cables to the cells. So it's actively monitoring. And if there's a dropout, there's a protection mechanism in there. If it's a multi-module pack, so that the battery doesn't, completely drop out. So you have some usable capacity in there as well. In terms of the reliability and the equalization, that's active inside of the FETs. So it's actively equalizing across all those cells. So what's important to note is the fact that the circuit board itself pulls a little bit of power. So you have to make sure that if the pack is fairly large, it's not a big deal, but if it's fairly small, you want to hit it with a charge every 6 months or so, so that equalization continues across all of the cells in the pack, because at some point it's gonna pull me about a couple milliamps, and that's just important to note as well. So
the battery will reset if you don't charge it up every once in a while, every 6 months or whatever you say?
Yeah, so that's a good question. So the circuit board, what it does is it has what they call PTC in there. So it has the ability to reset itself as well on the outputs. If you hit it with the charge current from the power supply, it's also taking as an input charge current from the supply to charge the pack, and then that equalization is going to happen regardless in that effect. Eventually, once you get to a completely equalized state, there's no reason to equalize anymore. So in that standpoint, you want to just you want to just make sure we hit it with a charge, so that'll just verify everything is functioning correctly as you move forward. And also the second reason is because we lose 3% capacity period with the chemistry if we do not charge it. You want to not lose that 3%. It's not, if you just hit it with a charge every 6 months or so, it's worth it because you're going to get all that usable capacity out of the battery.
All right. Next question we have here is, can these batteries be carried on airline flights? Is there any limits on transportation by aircraft?
Yeah, that's a good question. So right now it's limited to carry on to about 160 watt hours. So from what right now are trying to they're going to be expanding it out. So I want to say that they're almost ready to do that. I think the rules are about to change soon. It says right now batteries that are 160 watt hours can be carried on, but they may be expanding it to 300 fairly soon. I'm waiting for that information to come in. They got petitioned by the battery industry over the recent years to expand the watt hour requirement. DOT was petitioned. It's DOT, FAA, and TSA. They all, apparently it's all three organizations are going to work on that. But TSA is the one that's also going to be involved as well. So it's coming soon. The 300, it's going to be expanded out. But right now it's 160. So for carry on.
All right. Let's see. Another question we got here, is there an emergency override if you need more power, even if it wrecks the battery?
Is there emergency override if you know?
So I think if referring to the circuit board, can you bypass it to pull more current out in an emergency scenario?
Oh, that's a good question. Yeah, so you want to bypass the board because the way that the terminals, the wiring on the battery, these wires go to pads on the board. So there's the sense circuitry inside the board will detect the overcurrent. That's soldered. So we don't have a way to bypass that unless we were to mod it and put a switch to bypass it. But we don't really advise that because if you suck too much current out of the cells and the over discharge protection mechanism is overridden or you're basically overriding. You're just pulling from the cells. You can bring that voltage too low, so it defeats that circuitry that was required for the low voltage disconnect. Now, theoretically, if you were to do that and you don't bring the voltage below, 7 volts, then yeah, we'd be all right. But from as a manufacturer, we want to make sure that they're all protected. That's something that you get. But yeah, so the short answer is no. Yes, the overcurrent will trip.
All right. Another question here is, what is the stored energy mass? I'm not, Owen may be able to expand a little bit on what he means there.
You want the watt hours per kilogram?
That sounds
yes. Yeah, so the watt hours per kilogram for lithium iron phosphate batteries, about 220 watt hours per kilogram for lithium iron phosphate batteries. It is less dense than lithium cobalt oxide, but there's always a trade-off in engineering and physics or any science. So your trade-off is I have a lower energy density battery compared to lithium cobalt oxide or lithium polymer batteries, but I have higher degree of stability and safety. So we chose that as a company, and also the cycle life is also pretty critical from what we see in terms of what the users require. The value proposition is we're replacing a battery that if it was only 200, 300 cycles, something that's 2,000 to 3,000 cycles. If we were to offer batteries maybe like 700 cycles versus 200 or 300 cycles, it's not as appealing because you'd have to keep changing those out. But for your phone, it's okay. For your cell phone, fine, because it's a cycle, it's a lifespan that's the companies want are pretty short for those products. But for batteries, we want something that lasts longer.
Yeah.
I may be wrong, but isn't the energy density per volume higher than the lithium phosphate?
What's the reference? I guess.
Well, your
lead
battery
acid
is lighter for the same volume, isn't it?
Yeah, that's true. Yeah, that's true. So if we compare everything to lead acid, yeah, of course, it's much higher in terms of energy density. Everything is higher. All lithium chemistries are higher. I was comparing it to a lithium cobalt oxide battery that's in your phone. So with respect to lead acid, certainly it's much higher because it's a quarter of the weight of a lead acid battery, and I can capture all the capacity out of it.
Okay. All right. Another question we got here. How different is the charging process from a LiPo battery? And also, can a BMC designed for a LiPo be used with a LiFePO?
Sorry, can you repeat the question?
All right. So it's kind of a two-parter here. How different is the charging process from a LiPo battery?
So lithium polymer batteries, they have no circuitry built into it typically. So an RC LiPo battery that's at 11.1 volts or 14.8 volts found in RC cars, there's no circuit board in the battery. So they use a special balancing charger that is doing the balancing, equalization, and monitoring the cells. But because these batteries have the balance board, the balance circuitry built in, the battery sees a voltage that's between 13.8 to 15 volts. That's the power supply that's charging it. And then everything is handled internally through the circuit board inside the battery.
All right. And then I think the second part of this is, can a BMC designed for a LiPo be used with a LiFePO, I guess?
Okay, yeah, the BMS, I think, is that
Yeah.
correct? Is that, yeah. The battery management system, the voltages for a LiPo battery are different than the lithium iron phosphate, 12.8 volt nominal voltage. The BMS for LiPo batteries are about 11.1 or 14.8. So you have to match the voltage. The second issue is what's being implemented on other circuit boards. Some only implement balancing only, and there's no low voltage disconnect. So I would advise that if you were to use another BMS, if you were going to build a battery, you want to make sure, and if you're doing a DIY battery, you want to make sure you have a low voltage disconnect inside that board on top of the balancing of the cells. Those, at a minimum, those two. The over voltage and over current protections, those are good. I mean, that's what we put inside the batteries. We implemented that because we wanted to protect the cells from too much discharge in terms of a voltage drop as well. So we don't want to have too much current being and then bring that voltage down too quickly. But may not be completely required if you're going to do a DIY battery. That was the question.
Okay. I think that's it as far as I can tell. All right. Is a automobile truck charging system stable enough for charging?
Yeah, that's a great question. So we have a lot of questions about DC to DC charging. And so the issue is the alternators on the vehicles, from what I've seen for all modern vehicles, it's going to be somewhere between 14 to 15 volts. I've seen some things where the alternators on very old vehicles, if you measure the voltage at the car socket or cigarette lighter, there's some problems with voltage drop. This is on older cars that are maybe 20 years old or something to that effect. So if you have a voltage drop at that point, the issue is that voltage is not enough to completely charge the battery. The second issue is you need the on the charging current side of these batteries, you need to current limit on the input charging into these batteries. The output, we've implemented the overcurrent protections on the discharge side. So on the charging side, the current limiting should be also implemented via the Epic PowerGate's one example. So you need to add that in there when you're charging the batteries. So that's important to note. And the Epic unit does all of that. So if you use the Epic, you can use a power supply as an input, or you can feed the alternators into that Epic unit and then attach the battery in there. So you would just plug in the battery into the Epic. You take the alternator, feed that into the Epic unit, and then plug in the radio. Then it will give you all the status information to handle any kind of variance on your power supply input. That's probably the easiest way to do it. And from what we've seen, it's fully supported in that regard. So it's a good option to get that if you want to charge from alternator as a source. It does the job.
Okay. Got a question from Brendan. So let me hand it over to him because I think he wants to actually ask it himself.
Hey, Kevin. Yeah, I'd rather speak than type. It generally comes out better. I'm using an Epic. I have two Epics, one for sort of a go box with a 7300 and a Kenwood radio, where I hang either a 12 volt 40 or a 12 volt 50, depending on the day, just as a trickle charge situation in case I lose generator power or mains power. So as far as Bioenno, a 40 or a 50 longevity, so I'm not really cycling the battery, right? Because it's 90
partial cycling. Yep.
Standby, 10% full usage.
Yeah.
What are we looking at there as far as longevity? Am I actually extending the life of the battery?
You're extending it. Yeah, you should be saying, because you have not brought it to a complete charge and discharge, you haven't done full cycling of the batteries. So your service life has been extended out. We had, the original customers, it was like 8 years. It was still, we were asking what was the use case? How are you guys using it? And what they told me was they were using it for portable audio amplifiers. These are like large speaker cabinet audio amplifiers. They have an amplifier, and they would use it once a week. They were used in schools and things like that. And then they'd be put back in storage, and then they would then go put it on a charger, and they would go use it. So then we found that when we got one of the batteries back, the usable capacity, which was a 12 volt 12 amp hour, the usable capacity did not diminish to something we thought maybe like 80% of that capacity. It diminished like to about 94% or 95% across the 8 years. So, which was very interesting. That means that they were partially cycling the batteries for sure. So that service life was extended out. And that's another, if you wanted to do this test, when I guess Mark's going to be presenting at another date from West Mountain, there's something called CBA, Computer Battery Analyzer. They have it at HRO as well, other dealers. And they, that will actually measure, if you're really interested, you can see how many hours are remaining off the battery. And what that requires you to do is it requires you to do a full charge. Then you can fully discharge the battery and then see what percentage you're at on CBA number 4 model.
There was a buddy of mine owns one, so we did a test at Hamvention a couple of years ago, and overnight it was pretty impressive. Yeah,
it's been quite interesting in terms of the robustness of the chemistry, and we keep going back to the OEMs every year, that the original ones, because we want to see the time scale on it, the actual time scales on it. So.
Thanks, Kevin.
All righty. All right. So someone's asking if there is a catastrophic failure (parentheses fire) history, and if so, what?
Yeah, that's the nice thing about lithium iron phosphate batteries. If you go on YouTube and look up lithium iron phosphate and nail test, you'll see the test that they do. You get some like you see a little like fizzle, and then there's no fire. But you puncture a polymer battery, different story. The cobalt oxide is not stable in that regards. Again, that's the tight chemical bond. But yeah, go on YouTube, you'll see it. That's why we chose this chemistry, we focus on this quite a bit. It's a really neat test in terms of how lithium iron phosphate holds up from the stability standpoint. And that's why we're seeing it from the OEMs, not only the ham radio market, but from oil and gas industry, government as well. They do a lot of this type of testing in laboratories. In Detroit, they have the Army has a battery testing facility, and they'll put any battery in there for the test. And they've gone through every chemistry, and this is the only one that they can see it right now that is kind of holding up in that regards. And so there's some other ones that are coming out down the line, which have the same kind of characteristics, which will have, it's called a solid state battery, where the electrolyte's completely removed. It's just a solid piece in there. And it has higher energy density, has the same characteristics in terms of stability, where you can strike, nails and stuff through it and things like that. LTO is another chemistry, lithium titanate, same kind of thing. So things are going to keep getting better. It's just the timetable for batteries. It's like every 15 years as opposed to computers. Like CPUs, the number of transistors, the Moore's law, what is that?
18 months.
18 months,
Yeah.
it doubles every. Yeah. Well, it's
Yeah.
not like that in the battery industry. It's much slower.
It's understandable, though. Very, very different processes in play. All right. So another question here, and I think maybe some of the chat answered it, but I think probably good to give you a chance to say something about it. Is, can you communicate with the battery circuit board to get status or other information?
Yeah, that's a good question. So right now, the boards that we have don't have SM bus or CAN bus if you need that output. We have built them for specialty applications. We have I think 3 or 4 projects that we did it on. We can provide an SM bus, CAN bus version of the board. It adds to the cost. So it's meant for more we might be adding it on. It's something that we're going to be considering on our larger batteries, because we can make it work with the price points on those. But it's something we're considering. We might be adding also Bluetooth and things like that
Cool.
down the line. We're looking into those things as well. But anytime you start adding larger boards, more electronics, it has to make sense with the price of the batteries. So, but we're going to continue to evolve it as we go forward. For sure.
Cool. All right. Another question I have here, and I'm actually interested in this one as well. Is anyone making consumer UPSs using this chemistry yet?
The APC, is that the question? Yeah, those units. So
Yeah, APC or any UPS available.
Triplite APC, I know that they've been requested by a lot of customers to start supporting this particular chemistry. The APC units, my understanding is they have an output voltage of between 13.8 and 15 volts. So our 12-volt 9 will accept their charge current if you wanted to do the change on it. More expensive of battery, depending on how many years you change them out. I know customers that have done that change on telecom backup equipment, which uses the exact same, they're about this big 12-volt 9 amp hour batteries. They have tabs on the top, but they're not like big like this, they're about half the size. And they have tabs on it, but because we have the board built in, and if it sees that voltage, it will take that charge current. So I've had customers that have made the change out because they were changing out those APC batteries every couple of years, roughly, depending on how much it drops, how much power interruptions you had. Some customers are not changing the SLA batteries for a few years, so it's acceptable. But others, there are also some issues with remote sites. So for example, out here, we've done change outs on the repeaters down here with the PAPA system, and LA Sheriff's Department's ARES group, the Amateur Radio Emergency Service. We've done a change out for a 12-volt 200 amp hour backup battery system. So that's like 200 amp hour lithium iron phosphate battery, which is like 400 amp hour lead acid in terms of usable capacity. So in the event that they have power failure up on the mountain, our repeaters are on mountaintops. We're in a basin, so there are mountains right behind us. And so they've made changes to the repeaters, to the lithium iron phosphate. And what they've done is they've been able to, they do what they call an auxiliary power test. So they'll set up a failure scenario, right? And then it will go to the battery via their solar setup to confirm that the system is operating correctly off the batteries. So they'll periodically do that test. And they use the West Mountain Radio Epic unit. They take the USB output from it because it reads, I saw it in the chat right now, it will give you the amps coming out of the solar, and it'll give you the amps coming out from the Epic, telling you how many amps are going in and how many amps are going out. Then they send that over their connection up there back to whoever's monitoring it down here, and they can monitor these backup power systems remotely. So if they have a situation where, let's say, well, out here we have earthquakes, right? That's our concern. That's what knocks out power. For you guys, it's hurricanes or thunderstorms or tornadoes or something. So I'm not sure how much weather you guys get in DC. But you guys get tail end of hurricanes, right? I mean, it can knock out your power. Yeah, so.
We've had some good thunderstorms lately, too.
Big thunderstorms, too. So if you have a power outage on your repeater, and then if let's say you need to operate off battery, and you wanted to remotely connect into it, for some reason the power is out for quite a while, that seems to work quite well. And so they were able to demonstrate that quite a bit. And so, plus I got to go check out the site. It's kind of neat, to go up there. It's fun. So it's a hard drive because the roads are like these dirt roads that go up. These access roads are not very, very well in some areas. So it's worth checking out. I mean, there's a lot of ways you guys could do repeater backup, but it just depends on how many repeaters your organization is handling. We're kind of different out here because we have this private public partnership with Aries. So Aries here is more like we have our amateur radio club repeaters, then we have Aries repeaters. We have emergency service repeaters. So it's like both, and they're different. But you may be doing it differently over there. I don't know how that works.
Yeah. Honestly, I don't even know how it works.
I'm the local Aries EC here in Fairfax, is where we're located, and we have MOUs and relationships with repeater providers. So Vienna Wireless Society has an MOU with Aries. Northern Virginia FM Association, another organization, I'm on their board. We have a relationship with them. They have 7 repeaters, digital and analog. And then we have handshake agreements amongst friends at the Aries level for neighboring jurisdictions. So we don't have quote unquote Aries repeaters. We just have agreements where if an emergency were to happen, where the 911 system goes down or something bad happens, we prioritize the usage of the repeaters based on the needs of the emergency.
That's good. Yeah, I mean, if you wanted to run a test on a power failure, it's a good test to do because it will tell you if you have lead acid batteries up there right now. A lot of them, like right now, still have lead acid batteries in case the repeater power fails. It's a test worth checking out, just to find out what the runtimes. And they found out that the runtimes were they were significantly limited because they were running on some backup lead acid batteries, and they were trying to figure out, well, okay, if I was out of power for 24 hours or 48 hour scenario, what's my runtime off these lead batteries? And they had to run the test. They had to do this and then switch over. They had to set it up and then do the switch over and then switch back and things like that. But it's more experimental to some degree, depending on the age of the batteries you have. It's complicated to test. I'm just trying to say it's not, you have to go, because you're going to take something offline or switch it off or move it over to battery for a bit and see what's going on and do like a drill.
We've got one other question from someone else, and then I do have one question of my own as well. First question is, where are the batteries manufactured?
Yeah, we have a facility here in Santa Ana for assembly of the batteries. So all that packaging we do over here. You can feel free to come and visit. We've given tours to come and if they want to see how the batteries get built. But there's a lot of spot welding involved. There's a lot of assembly. Right now, it's done by hand in terms of the packaging of the batteries. We're getting more automation as we go forward. We have some plans for that. But you know, as things move forward, that's going to be one of our plans. I know the customers that are working in the robotics industry, they certainly are interested in roboticizing a lot of stuff. So I don't know if that's something we're going to look at down the line. But there's a lot of spot welding. The cells get put on a tray, and then there's spot tabs, and then there's a circuit board that's attached at the end. Then it has to go to the analyzers, and then you have to do this. You have to do a burn-in test where it's like you cycle the battery, you bring it down. That's all done real time. So in the battery industry, there's a couple ways you can assemble batteries. One is you can do 100% check, which is what we do, or you can do batch tests. So you do batches, but the way that most manufacturers have done it is it has to be 100% checked on the analyzers on each one of them, from what we've seen. I mean, that's the reality behind it. And you know, we're looking at ways to figure out what are the ways to optimize that, but that can be a bottleneck in some degrees in production.
Interesting.
Same with the car industry. Electric cars have the
Yeah.
same. They have to go through these burn-in tests. These really large 70 kilowatt hour battery systems
Yeah.
that we assemble for Teslas and things. The same issue that they have. I've talked to enough people in the
Yeah.
battery industry. Everyone's going through the same. They said, yeah, we got to put on the analyzer too. So we got to do our tests on the pack.
Yeah, that kind of actually goes into my second question. Now, granted, I wasn't thinking of cars. Since I worked in the rail industry, I was thinking of large batteries, you know, and if you guys, how large you get, because, you know, of course, this could go out to other industries. And obviously, like I said, the rail industry being one, there's a lot of uses out there. So.
Yeah, so I think in the rail, it's, I want to say it's nickel iron. Is that right? No.
I didn't deal with the battery person in the rail industry, so yeah. That's the curiosity, but yeah, you probably know better than I do.
Yeah, it's about, the largest we do right now is 3.6 kilowatt hours, which is, we can do it at any voltage. It's either a 12 volt, 300 amp hour. We go up to 48 volt systems. Typically when you're dealing with really high powers, it's different than radio. Radio tends to be, you're all 12 volt at 13.8 systems. But if you start running inverters, you're driving a lot of power. If you're doing any kind of inversion, then you go to a higher DC voltage. It's more efficient. The inverter runs better at that higher DC voltage. You can get 12 volt inverters where you're dealing with very large currents. And when your current goes up, then you get resistive loss and things just get worse and worse. You'll see voltage drops everywhere. And what you do is you just go to a higher voltage, then you keep everything up. Electric cars are the same. That's why they're all high voltage platforms. So what we can do, you know, up to 3.6, we have modules where we can do scaling. So if we need to go very large packs, we've done up to 30 kilowatt hour like modules. Well, a system that has various modules that get to 30 kilowatt hours, which is fairly large, 30,000 watt hours. This is 108 watt hours, is 12 volt 9. So 108 is like 0.108 kilowatt hours. 12 volt 12 is 0.144 kilowatt hours, 144 watt hours. So if you can imagine like 30 kilowatt hours, 30,000 watt hours, you know, it's, you know, you're looking at, you know, quite a bit of these in terms of size.
Cool. All right, let's see. So we have a question that kind of goes back to one of your previous answers is, do the bare cells use cell also pass such tests?
The bare cells, yes, the charge and discharge tests, the cells that we have, yeah. So these, it's the same concept. There's a charge and discharge. There's a nominal voltage that these cells sit at, and then there's a charge and discharge test that's done to verify the capacity of the individual cell. So if you verify the capacity on the cells, it's not sufficient when you build the pack. The reason is, there's a couple of reasons why. One is if there's any kind of if operator technician error in assembly, that's number one. You still have to verify that. That eliminates that. And then the second is you have to verify that everything is getting equalized correctly. So that requires us to still use the analyzer to verify the equalization is working across all the cells. If everything comes out of the same batch of cells, the internal impedance is all the same for every cell in the same batch. But if there's any, for whatever reason, some variance that happens, which is very rare, I've never seen it, you still have to run the test on the final pack itself. So in the battery industry, they still do that at the cell and then the whole pack level, from what I've seen and what I've heard. Yep, that's what happens.
Okay. All right. Thank you. I got one last question, then I think we're gonna close our meeting here. And so if you're willing to entertain one more question.
Yep.
All right. So Brendan's asking, Epic PowerGate versus BuddiPole device. Do you have an opinion, and is it a fair comparison?
Okay, the charge controller. So the BuddiPole device, they both work perfectly fine. I mean, they're fully compatible with the batteries. The BuddiPole has a digital display that's on it. The Epic does not, and requires the USB interface. My understanding is the Epic allows for the solar panel as an input, also your power supply as an input. So you're allowed 2 inputs on the Epic. The BuddiPole, I'm not sure. It may allow for both inputs, solar panel and the power supply. I don't know if it does. I believe it's just the solar panel, but I could be wrong. Both companies had approached us when they were building their products to evaluate it with the batteries, and it's 100% compatible. So you can choose whichever one you want, no problem. So they both work fine. The only thing is, the other issue is the alternator as a charging. I've not confirmed the BuddiPole unit to allow for the alternator as an input. Theoretically it should, but you may want to confirm with them as alternator as an input. The Epic, we've confirmed. So we've confirmed that, number one, it can charge from an alternator. Number two, it can be charged from the power supply. BuddiPole should be able to do that, because if it allows for that variance on the voltage input, then yeah, then it should work.
Okay, cool.
For charging the battery.
Thanks, Kevin.
Yep, no
Awesome.
problem.
Well, Kevin, thank you so much. This has been excellent. I know I've learned a lot about batteries, and I have to thank you so much for taking all the time to answer all the questions. I know we got a lot.
Yeah, no problem.
Really
Let us know if you have any questions. This is a good format. I think we're able to answer all the questions. We're all at home, so we have a lot of time on our hands, So
yeah. Well, everybody throws the questions at me, so I sit here just asking away, and it's kind of I kind of like this format. It's easy because I can filter all the questions into one question at a time. So it's nice to also have somebody who can answer them and is readily available to do that, and happy to do so. We really appreciate that, Kevin. So thank you so much.
Very, very good. Thank you.
Yeah.
All right. Well, I appreciate the time. Thanks for the invitation, and have a great evening.
Thank you. You too.
Thanks, Kevin. Take care. I'll be in touch then. Thank you.
I'll be dropping out. Thank you. See you. Bye-bye.
All right. Thanks.